Okay, so yesterday we learned the process of taking a product in which one factor varies is called the definite integral. The geometric interpretation was the area under the curve. Note, area under a velocity curve gives what value? It gives distance. Yesterday you learned to approximate the area or definite integral by doing what? What did we do yesterday? Riemann sums. Yeah. And his name was Georg, G-E-O-R-G, Georg Riemann. He was born in 1826. He died in 1866. Yeah, whatever. He has a big beard and wore glasses. And one heck of a comb over. What? Yeah. Yeah. Okay. So we learned by doing, so we took a curve and we built rectangles. And the type of rectangle we used depended on if we were using the left endpoint or the right endpoint or the midpoint. And then we decided that even better was trapezoids because they deal with the slopey bits better. Slopey bits. That's so bad. It's awful. Anyways. Yeah. Well, it's not so much above or below. It's so. Let's just draw a. So let's say this is the curve that I want to find the area under. And if I say use the right endpoints, watch how I start. I'm actually see how I'm defining? But if I say left endpoints, watch how I define it now. Some of them will repeat. Well, it depends on where you start. Depends on where you start. If you look at a table of values, and I say use the right endpoints, and I want the area between 0 and 5, I do these ones. And if I say left endpoints between 0 and 5, I'm missing number 4. Oops. I do those ones. Okay. That it doesn't matter if it's above or below, it matters what it is. Okay. Okay, so consider the Riemann sum. So I have a curve and I want to find the area from A to B. It says use n intervals of width delta x, where delta x equals, what did we use yesterday to figure out how our table was going to count by? Good. B minus A over n. So what we would do is, so you're using left endpoints here, Mr. App. Yeah, that's right. And of course all these have to be the same width. I didn't pass art, so you can laugh at me. But the y values were f of x, and the widths were delta x. So what I would ask you to do is to add up and we would start at 1 and we would go to n number of strips, and it would have a y coordinate of f of x, and I'm going to call it I, and that's the length of the rectangle, and the width of the rectangle would be delta x. And that would give you the area. That's what we did yesterday. I just didn't write it with sigma notation. We found the y coordinate, we multiplied it by the width, we added them together. And we did it as many times as I asked you to. Yeah? Can you see why I might use sigma notation? It's a fast way of saying add them all up. Okay. So how do we make it better? Well, instead of having n strips, we have an infinite number of strips. Now, we're not allowed to write it like this, because you can't count to infinity. Anybody want to try and count to infinity? Yeah. So what we do is we take the limit as n approaches infinity of f of xi times delta x. So what we're doing is just making the widths of the strips. We're making b minus a over n really, really, really small. It's almost like taking a piece of paper on the edge and looking at it, right? Does it have any area? When you look at the piece of paper on edge, does it have any area? No. But if you took a stack of 50 pieces of paper and looked at them on edge, do they have area now? Yeah. So that's what we're doing. Is we're going from rectangles that look like a piece of paper face on to fold it in half and look at it, to fold it in half and look at it, to fold it in half and look at it, to go to, so it's getting smaller and smaller and smaller. We're using more and more rectangles to find the area, and then finally we're going to a rectangle that looks like a piece of paper on edge. That's what that notation is saying. Go from a really big rectangle to a smaller one, to a smaller one, to a smaller one, to a piece of paper on edge, and then even smaller than that. A micron thick. Physics people, you should like that. He's using sciencey terms. Now, what does it have to do with this? It is this. Okay, now what does the definite integral have to do with the indefinite integral? Okay. So what I would like you to do is let's graph the line y equals x. Oh, that's awful. Nobody even commented on it. And I have some coordinate a, or some x coordinate a. What's the y coordinate? F of a. But what's f of a for this? It's a, because it's a nice... Okay, and then up here we got some coordinate, x coordinate b. If we go up to the line, what's its y coordinate? B. So it's b comma b. And I want to find the area under that curve. What shape have I colored in? A what? A trapezoid. So the area of that yellow shape, area of the trapezoid, is 1/2 b1, which is the y coordinate a, plus b2, the y coordinate b, times the distance between a and b. What's the distance between a and b? B minus a. Okay. Now we're going to clean this up. I'm going to FOIL this together. Get all math 10 on it. Would you agree that that is the area, that yellow shaded area? What's the antiderivative of x dx? Good review for chapter 6. What's the antiderivative of x dx? 1/2 x squared plus c. Mr. Rapp, anybody care to take a risk and tell me how I'm going to get the answer above? Take a risk. Okay, you both said the same thing, just in different ways. Substitute a and b in for x. Yeah, is that what you said? Okay, I heard equations. So if you watch, if you put b in for x, and you put a in for x, take a risk. How do you get the line above? Subtract them. So, Mr. App, do I really need to do Riemann sums to find areas? No. All I need to do is find the antiderivative and then substitute the two numbers in for x and subtract those numbers, and it will give me the area between the points that I'm interested in. No? But?
So you're subtracting the bottom one from the top one?
The top one from the bottom one. Well, it's kind of, because I don't usually write it like this, I subtract. So my yellow one is one calculation, my gray one is the other one. I subtract the gray one from the yellow one. Yeah. Okay, so if I want the area from 2 to 3 of x dx, what I'm saying is you need to find the antiderivative. And to find the answer, you're going to substitute 3 in for x. And you're going to substitute 2 in for x. And you're going to, and then, so 3 squared is 9, 9 over 2 plus c minus 4 over 2 minus c. Hey, Mr. F, it's 5 over 2. And then your hand shoots up and say it to me. I don't believe you. Oh, come on. Say it. I don't believe you. Good answer. What? You've been in my class all these years and you still don't believe? So then you go, then I take you here and I say, oh yeah? Oh yeah? You're going to be like that, are you? So we graph it. And then I go second trace, find the area. Option 7, 2, 3, 2.5. 5 over 2. Second trace, option 7, find the area between 2 and 3. Isn't that super fantastic? It's a beautiful thing. Okay. So flip the page.
And you always take, you put the top, so
Yeah. Yes. Doesn't matter. Okay, so my point is, okay, so let's do it. Doesn't matter. Yeah. So I mean, I was going to start, okay, let's do with y equals x squared. And then let's do the area between 0 and 4. How many strips do we want to do? 2? So 0, 2, 4. 0 squared is 0, 2 squared is 4, 4 squared is 16. Are you going to use left endpoints, right endpoints, midpoints, trapezoids? Trapezoids. So we're going to go 1/2, 0 plus 4, and the distance is 2, plus 1/2, 4 plus 16 times 2, and we get 4 for that one, and we get 20 for that one. So our area should be about 24 units. So then we go, okay, Mr. App, take the antiderivative, 1/3 x cubed plus c. And we're going to substitute 4 in for x. And we're going to substitute 0 in for x. Our c's cancel. That's a good thing, let me tell you. And then we go 4 times 4 times 4 divided by 3. What's 4 times 4 times 4 divided by 3? What? No, this is an approximation. This calculation over here is an approximation. It's not, don't say they're the same. The only way we say it they're the same is we don't do 2 strips, we do an infinite number of trapezoids. 2 trapezoids will not approximate very well. It should be, within a factor of 10. What's 4 cubed divided by 3? (21). It's pretty close. No, this is the area. This is an approximation of the area. But you can tell a grade 8 to do this. Why would we ever do it this way? Because we need to start somewhere. This is the history lesson. Unless I say use a Riemann sum. If I say use a Riemann sum, this is what's happening. If I say find the area, then this is what's happening. Are we clear in the differences? This is a history lesson. I mean, 1700s. This is developed before Newton and Leibniz had the idea of calculus. This isn't calculus. This is just area calculation, right? But making the link between this and this is calculus. This is what the fundamental theorem of calculus is. It's the link between area calculations, old school area calculations, and new school calculus notation. Okay? Which is pretty bleeping powerful. Okay. Too many things open. Let's close some of these things. Okay. So therefore, okay, so if f of x equals, if the antiderivative of little f of x dx is equal to capital F of x dx, capital F of x, where f prime of x, then it's just, this is the fundamental theorem of calculus. This is it. It's f of b minus f of a. Okay? This is it. Okay? Now, go back to your homework. What is the approximation for the following definite integral? Use the fundamental theorem to find the exact value. Okay, well, whatever. Let's just find the exact area. The antiderivative between 0 and 2, x squared dx. What are you going to do? X cubed over 3 plus c, and we're going to find the area between 0 and 2. So what are you going to do? 2 cubed divided by 3 plus c minus 8 over 3 plus c minus 0 over 3 minus c. C's canceled, they have to. And you're left with 8 over 3. Yeah. Oh. Okay, so good question. What happens if the curve isn't above the x-axis? So this is where it starts to become very interesting mathematically, and you have to make some interpretations. If I ask you to find the area here, you're going to say the area is positive, right? If I ask you to find the area here, you're going to say the area is negative. Above the axis is positive area. Below the axis is negative area. You can have negative area. Because if it has meaning, mathematics, we don't care. It's physics when it starts to have meaning. If I ask you, if this is work equals force times distance, right? Just a sec. Whoa. Whoa. So this is distance, this is force, and I want the net work, you would say it's 0. Now can you see the implications? Economics kids that are interested in business, right? If this is my my revenue function, and I want to know my total income of my company since it started, woo, positive total income. Maybe at some point in the future, the areas underneath match. So I'm not actually, my company's not in trouble yet because my profits have offset my losses, and I'm in the position where I'm okay. But if this area down here extends so that there's way more negative area, negative income, right? That the company's in the black. General Motors had this problem. They made money for a long, long time. Woohoo! That's awesome. They lost money. They lost money until about 2008. 2008. Let's say the 1990s, and I'm going to throw numbers, but that's just to 2008. They lost money. Well, they can afford to lose money because up here they were making money. But they got to a point where the negative area, the negative income, total income, was bigger. They couldn't take it anymore. So what they do? They went to the government. The government gave them a loan. Blah 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 blah. Do you get the idea of negative area now? You can have negative area. I'm not going to ask you to go out and floor a house and say how many square feet are in that room. You're not going to say negative 23 square feet. But what you can do is have some understanding about what the negative area means. It can be negative income. It can be negative work, like positive work, negative work, they cancel. Anybody who works with electronics, or when you guys do electromagnetism in physics, positive charge, negative charge, total positive charge, total negative charge. Do you guys talk about those things? Physics 12, have you guys talked about electrostatics yet? So you didn't talk about, oh, okay. Well, you will. So I'm getting ahead of your Physics 12 teacher then. You will talk about, we can talk about the total charge in a cloud. That's what plasma is. You take a gas and you ionize it. And we can talk about the total charge in the cloud. It can have a total negative charge. Yeah? You see how it, positive and negative are just interpretations. Right? They're not so much quantities, they're interpretations of quantities. You need to be thinking about that. It's like, y is negative to the left. It's just an interpretation of a quantity. So you need to be thinking about those things. Okay. Anyways, evaluate any more. Oh, GG. Evaluate more definite integrals. Okay, if there's nothing next to the dx in the integral sign, what has to be there? 1. So the antiderivative is x plus c, 3 to 6. Well, okay, so I figured it'd be kind of fun, but okay, so you can go 6 plus c minus 3 plus c, and you end up with 3. Yeah, you can, I mean, there are times when, you know what, Mr. Epp, it's way quicker just to do this geometrically. But you know what? You need to know that we're being consistent here. We should get the same answer. You got a rectangle with a length of 3 and a width of 1. 3 times 1 is 3. And you come over here and use the big heavy hammer to hit it, and you get the same answer. We like that. We like that. You don't want to get the same different answer. Okay, so next one. What happens when we change... Ooh, root of 2x plus 10. Mr. App, how do we do this? U equals 2x plus 10. So du over dx equals 2. So du over 2 equals dx. So what does the antiderivative become? Good. What next? Okay, now what? Oh, let's write it like the way we can take the antiderivative. U to the 3 over 2 times 2 over 3, good, plus c, times that by a half. Okay, now what? Not yet. Okay, so now what do? Now you put 3 in and negative 3 in. Oh, 3/2. Good call, sorry, I'm stupid. So then now you would put 3 in for x and negative 3 in for x, and you would subtract your answers. Anybody not like that half out front? You could write it as you could do that. Because the c doesn't matter. You multiply that half in, it becomes a half c. Big deal. What are you going to do with the half c's? You're going to subtract them anyway, so it doesn't matter, right? What? No, because 2 times 3 is 6. 2/6 is 1/3. Yeah. Okay. So you got to be careful. You're not going to use the negative 3 and the positive 3 until you switch it back to x's. Now, is that a lot of work? Do you want a different way of thinking about it? Do you want a step that will save you some time? Yeah? Are we interested in saving ourselves a little bit of work? Okay, when you switch to U, did everybody notice that I didn't put anything here and here? I deliberately left those blank. Did that bother you a whole bunch? Or did you even notice that or didn't even notice that I did it? Didn't even notice? Was there a sinking suspicion that App was leaving those blank for a reason? Oh. You guys don't even play along. Okay, well, whatever. Oops. Two times 3 is 6 plus 10 is... So, Mr. Epp, you could stop right here and put 16 in for you, and you would get the same answer. And you do the same exact... No, you still have to do the same thing. 2 times negative 3 is negative 6, plus 10 is positive 4. So you get to stop a line earlier. You don't actually need to do this one. You could put 16 in for you and put 4 in for you and subtract your answers. And you'd let you stop a line sooner. So it comes down to a personal taste and style kind of thing. What do you like better? Do we like that a little bit better, or no, we like going back to X is better? Pardon me? You like the first? Well, fine. I'm not forcing you to do it one way or the other way. Okay. The integral from 0 to pi over 2 cos x dx. Well, what's the antiderivative of cos? Sine x plus c 0 pi over 2 sine of pi over 2 plus c minus sine of 0 plus c. What's the sine of pi over 2? It is 1. Good. 1 plus c. Sine of 0 is 0. And you get an area of 1. Okay. 1. No, just 1. Okay, cos of x from negative pi over 2 to positive pi over 2. Oh, yes. Okay, so what's the antiderivative of cos? Oh, wait, it's the same thing. So we'll just skip all those steps. So sine of x plus c, negative pi over 2, positive pi over 2, sine of pi over 2 plus c, minus sine of negative pi over 2 plus c. So you get 0 plus c minus 0 plus c. No, sorry, 1 plus c, right. 1 plus c minus negative 1 plus c. Oops. Minus negative 1. Positive 2. No. 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 What? Oh, yeah, right. Yeah. You're right. Sorry. I'm dumb. Are you... Okay, surprised? What does this mean graphically? Well, what? Yeah, we're getting it myself. I was doing K. J. Well, what does it mean graphically? Well, okay, so what about way back earlier, and this is where it's starting to become sneaky, is cosine symmetrical over the y-axis? And because it is, I don't really need to do negative pi over 2 to positive pi over 2 to find the area between negative pi over 2 and positive pi over 2. All I need to do is find the area between 0 and pi over 2 and double it, because they're exactly the same. So sometimes there's tricks you can pull out. Hey, look, cosine is symmetrical over the y-axis. If I do the area between 0 and pi, and I know the answer between 0 and pi, and then I ask you the area between negative pi and positive pi, just drop. It's double. Yeah? Because it's symmetrical over the y-axis, I can instantly pull out the answer. Yeah or no? It's still the cos graph, yeah. Yeah. It's the area of the cos graph. It's not the area of the sine graph. You use the sine calculation to get the answer, but the area is of the cosine graph. Yeah. No, you're doing what I was thinking. I was getting ahead of myself and doing this one. So the antiderivative of sine So then you go negative cos of pi over 2 plus c minus negative cos of negative pi over 2 plus c. Cos of pi over 2 is 0, so you get negative 0 plus c minus negative 0 plus c What does this mean? Well, Mr. App, what it means is the sine graph, if I do equal amounts on either side of the y-axis, one area is negative the other area, so you're always going to get 0. Cool, huh? Point symmetry. The difference between line symmetry and point symmetry and how they can save you time. Did you hear me call them even and odd functions earlier? Cosine is an even function. It has line symmetry. Sine is an odd function. It has point symmetry. And because it's an even function, you can do the area really fast. Because it's an odd function, you can do the area really fast. It's a benefit. It can help you. Otherwise, you're going to just have to do the work, right? Oh no, what does this mean? It means you could save yourself some time. Okay, x cubed. Is that an even function or an odd function? Odd. Well, if you don't believe me. So what's the antiderivative of x cubed? 1/4 x to the 4th plus c. Negative 1, 0. So sub in 0. Sub in negative 1. Oops. You get c minus 1/4 minus c. You get negative 1/4, yes? What about, now, you're thinking to yourself, here's x cubed, here's 0, here's negative 1. Of course that area is negative, right? But if I asked you, okay, quickly, what's the answer to this question? Positive 1/4. Quickly, what's the answer to this question? 0. Why? Because it's got point symmetry at 0, 0. It's an odd function. Bang. Odd functions, when you're going the same distance from from 0, 0, when you add up the areas, you're going to get a net value of 0. See, if I tell you one thing, like here's the. So if I do this, and I tell you equals 7, and I tell you that it's even, yeah? Well, I'll do this. And then I'll ask you this. What's the answer? 14. You don't actually need to do any work. If I say it's odd, and I ask you the same question, the answer is 0. You say, because this function is even, the answer is bang, 0, and you're done. Yes, I expect it. Expect it. I don't expect you to do the work. I mean, how can you do the work? I don't give you anything to work with. Right? Okay. Mr. Epp, you're getting excited. Relax. Okay. Do the following without using the fundamental theorem. Okay, we've already done this one. What's the answer? It's 0. Right? It's up over there. So discussion in odd and even functions. How do you know if the functions, what functions do you know are odd and even? Well, is x cubed an even number, or is cubing an even number? Okay. So you look at the power. Look at power. What else can you do? Like, how did I know sine was an odd function? I looked at its graph. I looked at its symmetry. Yeah. So you either look at the power of the function, or you look at the graph. Look at graph for symmetry. For symmetry. Do we need to? Even is okay. Even is odd is. It's actually point symmetry at 0, 0. It's actually rotational symmetry at the point 0, 0. Okay. Almost done. Use your brain. What is the antiderivative between 1 and 1 of x cubed? Do not do any calculation. Thank you. The area between 2 and 0. Oh, we have to do some calculation. Oh, well. Have we done the area between 0 and 2? Have we done this one somewhere in our notes? I bet you have. Okay, what's the answer? What's the answer in your notes to this question? 8 over 3. I know. Oh, I know, sister. Mr. Abb. I'll draw the picture for you. Now, most times we color from left to right. Here we're coloring from right to left. When you color out of order, give me a guess. No. Negative. Out of order. So we tend to do this. I was going to actually, and then somebody shoots up their hands and says, I don't believe you. Thanks, Craig. So let's just follow what we've been doing. The antiderivative between 2 and 0, x squared d. So what's the antiderivative? So put 0 in for x. Put 2 in for x. And subtract. You're going to get a negative answer. Because the higher number is last. 0 plus c minus 8 over 3 minus c. So if you color out of order, so okay, another good multiple choice question, no calculator because you can't do anything with it. I tell you the area between a and b of f of x dx equals 12, and then I ask you the area between b and a of f of x dx. Negative 12. Hard? No. Oh yeah? How about this one? Nope. 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 Yep. Because I'm doing it out of order. So I would do the area between a, negative a, and the answer is 26. And now because it's out of order, the answer is negative 26. As soon as it's out of order, you change the sign on the answer if you were to do it in order. How's your brain doing? Which is kind of funky, hey? There's no numbers here. There's no calculation going on. It's just all information and visualization. Right? 0 to a, so there's 0, there's a. It's got an area of 13. There it is. And then even says, oh, cool, you get to flip it over, and it's exactly the same area. And then I say, instead of coloring from a to negative, I ask you to start here and color that way. That's why it's negative 26. You're coloring in the wrong order. So when you go to art class and you're coloring, you have negative coloring and positive coloring. So the observations made on the previous pages can be summarized as follows. If f of x is above the x-axis and the area is between a and b, then we can find it doing this calculation. F of b minus f of a. And we have a visual of that. We could a, b, yeah? If the area is below the x-axis, it's still f of b minus f of a, but tell me about the answer. A, b, area here is going to be negative area. So you can go and scare your grade 8s that you're helping with math. F of x is above and below. Well, you can have this then. But what we really like to know is where that point C is, hey? Because if I use the term total work, the difference between total work and network are subtle. Network is you would add those areas, and if I asked you the total work, if I asked you the total work, you would go, oh, I got to add this area, and I got to add this area, but I got to flip the sign and make that positive. That stuff below needs to be positive and added in. That's the distance between position and displacement. Or how far did you walk, total distance walked, and how far you are from the starting point. Right? If I take a grade 8 and I make them run 10 meters that way, and I make them run back 10 meters that way, and I ask you, what's his displacement? You're going to say 0. If I ask you how far the kid walked, you're going to say 20. So you have to watch what the question is going to be asking you to decide, do I get to flip up that area and make it positive and deal with it and add it in? Or do I treat it as a negative and just add it in, and the positive and the negative, and there'll be some canceling and it'll be all good? Yeah, net is like displacement. Total is like distance walked. Yeah, sort of. But yeah. Yeah, sort of. The ideas are similar. Okay, flip the page. Okay. If I ask you to find the area from A to B, okay, let's look at this. If I ask you to find the area from A to B, and then I ask you to find the area from B to C, it's as if I found the area from A to C all at once. But why would this be important to think about it in two separate places? Well, sometimes life ain't nice, and you'll have to go find that area, and then all of a sudden you have a change in the function. Oh, Mr. App, piecewise functions. You can't go from A to C all at once. You got to go from A to B, find that area, stop, find the area from B to C, stop, and add those two areas together because the function changes at B. Physics 11 kids should be used to that because you were used to doing the triangle plus the rectangle plus the something else to find total work. Right? So you have to be willing to split it up. Okay, what about the area between A and A? 0. What about the area between B and A? Oh crap, Mr. App. The letters are out of order. Negative. Watch out for symmetry. Look for even and odd functions. Okay, the last thing that I want to make sure that we know is the link that the area from AB, f of x dx, can be found using f of b minus f of a. But where does this all come from? It all comes back from this. This is like, you can call it the super fundamental theorem of calculus. Because it links rectangles or whatever method. F of x sub I is just your method that you're going to use to find that area, length times width. We could use midpoints, lefts, rights, or even trapezoids if I wanted to funky that formula up a little bit. But you need to see that the areas of the rectangles become the antiderivatives being calculated. Okay? They're all the same thing. Which one do we like doing most? I'm a fan of this. I've always been a fan of this because this is easy. I really didn't like doing this because it was a lot of work and it was tedious and I didn't quite get it. And I didn't get it because I don't know why. Maybe I refused to understand. But as long as you have in the back of your mind, all we're doing here is length times width and adding up rectangles. And if you use your graphing calculator to help you do this, have you played around with it a little bit using the second trace 7 button? Have you watched how it draws it? It actually draws rectangles. It does this. Like it starts at the top and colors down every single time. I know I'm weird. I notice those things. So you can actually physically see it drawing these little tiny rectangles each time. So anyway, you need to know this connection. I can't be any more blunt than that. I'm going to ask you to make this connection. So if I gave you, well, you'll see on the practice test for chapter 5, but I will ask you to make, I will write it in sigma notation and I'll say, how would you write it in integral notation? Or I'll write it in integral notation and I'll say, how do you write this in sigma notation? Yeah, but the implementation of the formula, but yeah. I always starts at 1, yeah. Because this is the counting of the number of strips. Okay? It's not A and B. You need to be told that somewhere else in the question. So I'll say find the area. So write it in sigma notation, write it in integral notation. Okay. I always starts at 1. Okay? That's it. Thank you for participating. The assignment is due Thursday. Test is next Tuesday for chapter 6. It mimics this really closely. It's not this long, but it's so if you're doing this and you're feeling good, then you should be okay. If you're doing this and it's not feeling so good, then you need to be talking to me and getting some help. Okay? Okay.